friends. This is Rajesh from Knowledge Institute of Technology. Today we are going to see about MTCMOS technology. So MTCMOS is nothing but multiple threshold CMOS technique. Usually, normal CMOS implementation for any kind of circuit will have a fixed threshold voltage. Okay, so instead of that, we are going to use a multiple threshold voltage transistors is nothing but empty CMOS logic. Let's see an example. If we implement a NAND gate by using CMOS logic. You can see from single library, I'm selecting transistors, PMOS transistor, and through NMOS transistor. So rearrange, so before NAND gate, two PMOS transistor will be in parallel and NMOS transistor will be in series. So for MTCMOS implementation, we are supposed to have two more transistors, that is one PMOS transistor and another one NMOS transistor. Okay, so as usual, we have two inputs and a single output. Okay, so to control the sleep transistors, that is additional this PMOS transistor and NMOS transistor, we are supposed to give one more input. Let us say this input as sleep. Okay, so this I am renaming it as B. This one I am renaming it as A. Okay, so just place supply and ground. So now we're supposed to connect all the transistors. Okay, connecting the logic as well as the two more transistors. PMOS here. Playing on inverter here because we have to give it for PMOS transistor and sleep bar to NMOS transistor. So here connecting with an inverter. Okay, now the connection has been done. So here you can see that if you want to remove the wire connection, you just click it will delete. So here you can see this is so your normal CMOS NAND gate implementation. Additionally, I am using these two transistors where these four transistors will have low threshold voltage, whereas this PMOS and this NMOS will have high threshold voltage, which means So by using this sleep input, we can control the NAND gate CMOS. Okay, whenever this sleep input is activated, so this PMOS transistor will be off and this NMOS transistor will be on. So whatever changes you have made at the inputs, it will not be reflected on the output side. So if you want to activate this NMOS circuit, okay, you have to make this sleep plus 0. Okay, so which means this PMOS transistor will be turned on and NMOS transistor will also get turned on. Okay, so now by doing this, so we can avoid the short circuit. Okay, short circuit that is from VDD to ground. Okay, so the significantly you can reduce the power consumption of the circuit. Okay, now let us simulate the circuit. Okay, now I have made this sleepers one. So one means this transistor will be off. So inverter you will get zero output. So this NMOS transistor will be off state. So if you change the inputs A and B, output will not get any output. Okay. Whatever the changes you have made, it will not be reflected at the output side. So now I am making this sleeper 0. So here you can see A and B inputs are 0, output will be 1. A equal to 1, B equal to 0, again output will be 0. Now both the inputs are 1, output will be 0. So this will work it as a normal NAND gate. Okay. Supposed to convert this transistor level into its layout diagram. So just go to File and make Verilog file. So it will generate the text file which is of in Verilog format. So now go to Micro tool to compile and select compile Verilog file. So choose that MTCMOS Verilog text document and just click compile and it will generate the automatic layout for my NAND gate using MTCMOS logic. Here you can see A and B are my inputs, Y is my output, sleep is to control the logic. So now just run the schematic. Here you can see the power consumption. So here the power consumption is 1.875 microwatt. Okay. So if you have already viewed my earlier video, here you can see without MTCMOS logic, okay, the power consumption here you can see is a normal NAND gate circuit without MTCMOS. The power consumption is 2.537. By using MTCMOS, you can see the power has been somewhat reduced by 40%. Okay, that is a role of MTCMOS. Similarly, you have another logic called as VTCMOS logic, variable threshold CMOS logic. By adjusting the bias voltage, you can able to control the power consumption. Okay, thank you.